Okay, hi guys. So we're going to talk about the graphical methods for two variables in this lecture today. First of all, let's see. So for our goal in the section today, we would like to explore the relationship between two variables. Those two variables can be quantitative, both qualitative, or one quantitative, one qualitative. Okay. Let us start with two quantitative variables. Okay. And we'll be using scatter plot to characterize the relationship between these two. So I will let you take a look at the introduction to this problem, which is talking about the number of beers versus the reaction time. I'll give you 30 seconds to read about the description of this experiment, and we'll see how that goes. So basically, the left column, as you see, shows the number of beers, the beer consumption, and the right column shows the reaction time, which is measured by a machine that rings a bell and it clocks the amount of time. Okay. And we'd like to see if there's any relationship between the number of beers and the reaction time of a person. So I'd like to mention that one thing that we can use to describe the relationship between these two is called scatter plot. Scatter plot is a visual way for us to see the relationship right away. Basically, you have one variable on the horizontal axis and the other one on the vertical axis. One can be called independent, one can be called dependent, or sometimes one is called, one variable is the the predictor, and the other one is being predicted. Okay. In our case, I would think the number of beers would be independent and a reaction time will be dependent on the number of beers. So if we use SPSS to construct a scatter plot, this is what you're going to see as the output. On the x-axis is the number of beers. Okay, number of beers on the x-axis. On the y-axis is the corresponding reaction time. And let's see the relationship between these two variables. Okay. Basically, we can see that the trend is going upwards, right? Well, as the number of beers increase, okay, going from left to right, my dots are also increasing. The reaction times are also increasing. In generally, you see these scatter dots. Okay, these are the scatter dots based on each order pair. And we can draw a straight line to fit these dots. So in this case, we would say that one variable increases and the other one also increases. There is a positive relationship right between the beers and the reaction. Okay, so positive relationship. Positive relationship. In general, we're saying as the number of beers increase, the reaction time is going to increase as well. Okay, let's look at another case, which is about two. Okay, which is about, let's see here. Yeah. Two qualitative variable. Okay, qualitative, which means the variables can be put into categories. Okay, qualitative. In order for us to investigate the relationship between qualitative, we're going to use a table, so-called the contingency table. Okay. In SPSS, it's also called the certain crosstab in SPSS. Now, suppose we want to look at this data set. One is the gender, one is the candidate. Okay. We would like to explore if there's a relationship between a person's gender and the specific preference of the two candidates. So we have these data being given. For example, the first respondent is a female and she actually prefers the candidate A. And the third respondent is a male and he would prefer the candidate A as well. So that gives you a sense of each respondent and their specific choice of the candidates. So we can use the contingency table, as we mentioned in the SPSS, okay, to generate a table looking like this. This is called the gender candidate, the cross tabulation. Okay. So in this table, we can see that the female and the males are put into the rows, and the candidate A and the candidate B are put into columns. So what we can know here is we can see that 6 people are female and also prefer A. 4 people are male and also would prefer B. In total, by using this cross tabulation, we see there are 13 females, right? 13 females. And in total, we know 14 people would actually prefer candidate A. And this number 25 is called the grand total, which is actually 25 respondents that has been asked. Okay, we can generate this in SPSS. In the video of SPSS methods, you can see how we get this how we can get this table generated. For this cross tabulation, we can always add certain percentages. Okay, and these percentages going to give you more information on the specific relationship between the gender and the candidate. Now, suppose we're computing the row percentage, okay, the row percentage. So you see each row is 100%, okay, being considered. So all the females being considered in the first row and all the males are being considered. So that tells us in the first row, 46.2% of the female would actually prefer A. 53.8% of the female would actually prefer B. Okay. Similarly, you can also tell 33% of the male would actually prefer B, and 66.7% of the male would prefer A. Okay. In total, okay, we see that 56.0% of people would prefer A, and 44.0% of people would prefer B. Okay. So that's what you get for row percentage. You can also compute column percentage, okay? Column percentage. So in column percentage, you are trying to set each column to be 100%. So 100%. Okay. So let's focus on the column A, which is considering all the people who would actually prefer A. So in this column, you can tell 57.1% are actually male. So that tells us like out of all the people who would prefer A, 57.1% of those are male. Similarly, out of 100% of people who would prefer B, 63.6% of those are actually female. Okay. So that's what it tells us for the column percentage. You will need to know how to interpret these tables, okay, by reading whether it's column percentage or row percentage. And the key again is looking for the 100%. If it's 100%, then it's talking about the entire column to be considered, which is only focusing on the candidate A. Okay? All right, there's also a way for us to compute the total percentage. Okay. Total percentage have 100%, includes all of those. Okay. And you can see 100% is basically everything being considered. Okay. Females who would prefer A, females would prefer B, males would prefer A, and males would prefer B. If we add up all these 4 individual percent up, you would be able to get 100%. So that tells us out of all the people that is being considered, 24% of 0 is females 24% of those are actually female who prefer A. 16% of those are male who would actually prefer B. Okay. So that's sort of like a frequency distribution. You put the frequencies in the table and look at the percentage. All right, so next let's talk about the corresponding graph when you're looking into two categorical data. For the graphs, we're going to look at sort of like a bar graph, but since we have two variables, gender, okay, and the candidate, gender and a candidate, we call this as the certain cluster bar graph. Now we have two simple cluster graphs that can be generated based on how you label the horizontal axis and the vertical axis. So in the first case, we put the gender in the horizontal axis and we put the preferred candidate in the vertical axis. So you got these two simple bar graphs given. And if you look at this graph, it basically tells you for the female cluster, the female would prefer the candidate B more than the candidate A. For the males, most of those would actually prefer A than the candidate B. Now you can also switch the x-axis versus the and y-axis. Okay, switch these two, then that gets us gender here on the y-axis and the candidate in the x-axis. By reading at this table, it tells us out of all the person who would prefer candidate A, there are more males than females. The second one tells us out of all the candidates who would prefer B, there are more females than males. Okay. It depends on your choice of the bar charts. Sometimes it depends on what you want to interpret, what you want to show in the result. All right, the last thing we want to talk about for two variables is one qualitative or categorical with one quantitative. Okay. So let's see this given data set. I'll give you 30 seconds to read the description of these two data sets. Okay, so basically they're talking about people who suffer from migraines and they were given two different treatments, right? Either one is given a medication or the other groups are not. And they're trying to measure the severity of their migraines and to see what's the outcome of the treatments. Okay, so we can see that treatment is categorical, which is qualitative, categorical, and severity has to be measured in numbers, which is quantitative. Okay. So we're basically looking at the relationship between these two variables, the treatment and severity. Okay, so you can use a graph, which is called side-by-side box plot, to talk about the relationship between these two. Okay, let me move the graph just a little bit down here. So we can see that on the horizontal axis, we have treatment. Okay, so two groups, one is not given the drug, one is given with the drug. And the vertical axis is talking about the severity of symptoms. Basically, the group of medications has lower values in general than the groups that is not given with the drug. And that's what we can conclude by looking at this side-by-side box plot. Okay, so that concludes our lecture for two variables and distributions. How do we use graphs and tables to show the relationship? Let me know if you have any questions. And all these graphs that has been constructed in the SPSS will be, you can see how you can get these tables and graphs in the other section of SPSS. So check that out. Thank you.